All right, we're still looking at the Pythagorean identities, but these are some examples that are similar to what we've seen on the state test in the past. So, of course, the state test, they always just word things a little differently to make it look confusing. Actually, sometimes these are easier, but you just have to know how to set them up. All right, so the first part of Pythagorean identities, when it says given, theta is between pi over 2 and pi. Okay, so that's just talking about the domain. That's talking about where it's located, so we basically know what sign it is. Okay, so if you think about the unit circle, this is a very bad circle, I apologize. But if we start here, that's at 0. And then we go up to here, that's 90 degrees, which is pi over 2. And we come over to here, 180 is the same as pi. We come down here, 3/2 pi, 270 degrees. And one complete rotation is 2 pi. All right, so why do we need to know this? Because we're talking about pi over 2 to pi. So we're talking about this region over here. Okay, so if we're talking about that region over there, how does this help us? Okay, well, if you're talking about this is the origin, if you come this way and go up, that's positive, positive. If we go left from 0, that's negative, and up is positive. So this side is negative, positive. If we go left and down, those are both negative. And if I go over and down, that's positive and negative. Now, you may say, what's positive and what's negative? Okay, when we're talking about the unit circle, the exact measure on the unit circle, when we look at the 30, 60, 90, and a 45, 90, you found specific measures along the unit circle. Okay, in each quadrant, they look similar, they just had different signs. Okay, so on the unit circle, it's always the cosine. Sorry about that. I didn't mean to move that. Cosine and sine. Okay, so that means your x value is your cosine, your y value is your sine, and the positive and minus comes from which quadrant it's in. Okay, so that kind of gives you a little bit of idea of what they're talking about here. So we're talking about this quadrant, quadrant 2, and we know that the cosine in that quadrant will be negative and the sine will be positive. So if we're given the sine, what is the cosine? We know that the cosine, okay, the cosine in quadrant 2 is going to be negative. So you may go ahead and look at the answer choices. If it's multiple choice, you may be able to go ahead and figure that out. But let's plug this in. So if I have sine and cosine, Pythagorean identities, we know that sine squared theta plus cosine squared theta is equal to 1. Okay? So if I come down here and I say sine of theta equals z, I'm going to plug in z. So I have z squared plus the cosine squared is equal to 1. Okay, so I'm going to subtract, because I'm trying to solve for cosine, so I'm going to subtract z squared from both sides. So I'm going to have cosine squared of theta is equal to 1 minus z squared. Take the square root. Cosine of theta equals the square root of 1 minus z squared. Now, we're done except this is negative, so when we have plus or minus here, this one we know will be negative because of the quadrant it's in, and that's the only reason. Okay? All right, the next one is asking for the cosecant if the sine is given. Okay? We are looking at the same quadrant, so we're saying the sine and the cosecant are reciprocals of each other. So if the sine is k, then the cosecant would be 1 over k. Okay, so in this example here, the sign is positive. The reciprocal of that is also positive, so that would be your answer. Okay, so again, these are using the same identities. They just look a little different because they're using variables instead of numbers. But again, sometimes on state tests, that's what they do. Okay, good luck.